All right, so I'm going to walk through a few more practice problems to just help you build up your confidence in solving these. So what I'm going to recommend is I'm going to read the problem, and then I'm going to tell you to pause the video. And pause the video, give it a try, and then look through the solution and try to figure out where you're getting it right and where maybe you're possibly struggling. Let's take a look at sample problem 1. It says, Keisha needs $12,000 to buy, sorry, that should say B-U-Y, the used car that she wants. She puts $10,000 into a savings account that earns a 1.3% interest, compounded semi-annually. How long will it take her to get the amount she needs to buy the car? Okay, so the first thing we always recognize is we are going to be using our compound interest formula, which says that the balance is equal to the principal times the 1 plus the rate over n to the power of nt, right? Now, first thing I do is I identify what information I know, right? So we know that she needs to have $12,000. So that there is our balance. We know that she currently has $10,000. And remember, that's our principal, the amount that's deposited originally into the account. We know that the rate is our percent, and we're going to put that here, but we're also conscious of the fact that when we plug in the rate, we always plug in the decimal version. So we know it's 1.3 over 100, which is 0.013, and that's what's going to get plugged into our formula here. And we know that n is the compounding frequency, and we can see here that that is semi-annually, which means 2 times per year. So we know that n will be 2. Now, the only piece of information we don't know is how long. In that case, that's our t. So the first thing we do is we go ahead and we plug in everything they tell us, right? So we have 12,000 is equal to 10,000 times 1 plus 0.013 semi-annually. And then the simplest thing to do first is to simplify the portion that's inside the parentheses. That's kind of always where I begin. So I'm going to take 1 plus 0.013 divided by 2. And you can see that that's a 1.0065. So I'm going to put that here, 1.0065. Now you will notice that I do not round that and I don't say 1.007. If I round too much, it will create an inaccurate answer, right? It'll be too much of an estimate. All right, so now we're going to go and we're going to try to solve this equation for the variable t. Now, with solving equations, we always want to reverse PEMDAS, right? So in order of operations, we always do what's inside the parentheses first, right? Then the exponents, multiplication, division, and then addition and subtraction. But with solving, we always do this in reverse. So the first thing we're going to ask ourselves, is there any addition or subtraction in this equation that needs to be removed? I don't see any. Is there any multiplication or division? I see it, right? Right here, we see that 10,000 is being multiplied. So we're going to divide by 10,000 on both sides, because remember, the objective is to get that variable t by itself. So anything that's on the same side of the equation with the t, it needs to go. So I have 12,000 divided by 10,000, right? And let's take a look with our calculator really quickly. I know some of us can do this easily in our heads, but just to show you that we can easily do this with a calculator, we'll do that quickly. And we see that we get 1.2 is equal to 1.0065 to the power of 2t. Now, we learned recently that in order to remove a variable power, we use logarithms. So the simplest method is simply to take the common logarithm of both sides. So we're going to take our log base 10, or just log, of 1.2, and our log base 10, or just log, of our 1.00, sorry, I'm missing a 0, 65, and that's a 0, to the power of 2t. And then we're going to use what's called the power property, which says that if I take the log of the power, that the power itself can jump out front. So this actually becomes log of 1.2 is equal to 2t times the log of 1.0065. Now, why is that important? Well, it's important because now the variable is no longer a part of a power, and now we could solve. Now remember, our objective is to get that t by itself. Right now, next to the t, we see a times 2 and a times log of 1.0065. So because they're both being multiplied, we're going to divide by both of those. So I'm going to divide by those on both sides. On the right, they cancel. And then we can see that we are left with just t on the right side. And then to do this calculation, this log of 1.2 divided by 2 times log of 1.0065, we're going to use our calculator again. I think we've talked about this before, but let's talk about it again. When using the scientific calculator on the computer, in order to do log of, we have to put the number, then log. And then note that when I do the division here, because I want to divide both by 2 and log of 1.0065, I must put parentheses around it. So you'll notice up here in my calculator that I'm putting the parentheses. So I have log of 1.2 divided by 2 times our 1.0065 log. And you'll notice that it's typed incorrectly. If you look closely here at the calculator, you could see that it matches what I'm hoping for. And then I hit enter. And I could see that it is about 14.07 years. So I'm going to say about 14 years. I could say 14.1. I think that's probably going to be favorable. So 14.1 years. Now, the cool thing about this is once you get your answer, you can check it. And you can make sure that what you're getting actually makes sense. Now, the simplest way to do this is going to be to get into Desmos and to type in your information and see that it works, right? So we know that Keisha, let's go back here, started with the 10,000, right? And that her interest rate was a 1.3%. So we have that 1.3%, that it was semi-annual. And all I'm doing is just going to plug in the answer we got 2 times, and then we got, what was it, 14.1 years. So I'm going to plug in a 14.1. 14.1, and we could see here that at 14.1 years, she has about $12,004. And remember, our objective was to get $12,000. And I would argue, and I'm hoping you guys agree, that that is pretty close.